Chapter 24, Part 2, we are going to talk about hypothesis testing for two samples. So because we're hypothesis testing, we're still going to be running through our acronym of PHANTOMs. The only difference is this time we are going to have two samples or two groups. So we're going to be testing to see if there is a difference or an increase or a decrease between these two samples. With hypothesis testing for two samples, we are again going to have two hypotheses, so a null hypothesis and an alternative. With our null hypothesis, we're always going to start with assuming that these two groups are equal. So I'm going to write this as mu1 minus mu2. Equals mu2. I'm assuming that they are equal. Now, just like we did with proportions, I want these two averages to be on the same side of my equation. So I'm going to subtract this mu2 to the other side, giving me mu1 minus mu2 equals 0. Your null hypothesis should always be equal to 0 because we're always assuming that the averages are the same. For my alternative hypothesis, I can try to show that mu1 is less than mu2, so the first average is less than the second. Subtraction there would give me mu1 minus mu2 less than 0. Or we could try to show that mu1 is greater than mu2. Again, if I subtract that second average over, I have mu1 minus mu2 is greater than 0. Or we could have a two-sided test where we would try to show that mu1 is not equal to mu2. Again, subtraction gives me mu1 minus mu2 not equal to 0. Okay, before we jump into a hypothesis test, I do want to just recap the formula for standard deviation. Okay, we saw this in part 1 when we're finding the standard deviation of the difference in our sample means. So that's x bar 1 minus x bar 2. We said to take the big square root. You're going to take the standard deviation of your first sample, so S1, and square it. Then divide by your first sample, which is N1. We add the second standard deviation, so S2 squared, and we divide by the second sample, which is N2. All right, let's go ahead and look at an example here. So example 1 says a random sample of 13 men and 19 women in a college class reported their grade point averages or GPAs. Here are the histograms from the data. This is extremely hard to read. This is an M here, so this first one is for men. The second one is for women. I'm sorry that it's so hard to read. Okay, they also give me the summary stats for this data. So for men, they had an average GPA of 2.898, standard deviation 0.583. Women is listed right below it. Okay, a woman in the class says that she believes that college women tend to have higher GPAs than do college men. Does this sample support her claim? We want to test an appropriate hypothesis and state our conclusion. Okay, now we're going to go through phantoms again. So in P of phantoms, this stands for the parameter. So we're going to list what we think is happening in the population. Now for hypothesis testing for one sample, we just listed what mu was, right? We said mu is, the average GPA would be 4. The average GPA would be 3.5. Well, now I have two groups. I have men and women. So I'm going to have mu1 and mu2. Okay, I like to go in order here. So it looks like in both cases they listed men first. So I'm going to have mu1 represent the average GPA for men. My second group will be the average GPA for women. Now, hopefully you notice I don't have any actual number values here. They did not tell me what we think the average GPA for men and women is, so I'm just going to leave this part kind of broad. mu1 is just representing the actual average GPA for men. It doesn't give me a number value, so I don't need to put one there. H in phantoms stands for hypotheses. So my null hypothesis is where we start by assuming that men and women are the same, so their average GPAs should be the same. So my mu1 would be equal to mu2. Subtracting over gives me mu1 minus mu2 equal to 0. This is my assumption. Men and women are the same, so they're going to have the same GPA average. Okay, alternatively, we're trying to show something different. Okay, we are saying she believes that college women tend to have higher GPAs than college men. So I'm looking for women to be higher than men, so that means mu2 will be greater than mu1, or mu1 less than mu2. I'm going to go ahead and subtract, so mu1 minus mu2 less than 0. If you decided to put mu1 women and mu2 as men, this inequality would be switched around, so that's why it's so important that you list in P what your variables are representing. Okay, A in phantom stands for our assumptions and conditions. We're going to check the same assumptions and conditions as we did with our confidence intervals for 2 samples. So the first one is that both samples need to be random. Right, it says that this was a random sample, so that first condition is met. The second condition is that both samples must be less than 10% of the populations. I definitely think that 13 men and 19 women is less than 10% of all men and women. In my third condition, I'm looking for nearly normal. Now, sometimes we have to make this histogram or normal probability plot on our own. In this case, they gave me the histograms for both sets of data, which is kind of nice. I can just take a look at both of them. Okay, although you might argue the men is a little bit skewed to the left there, for the most part, that's looking pretty normal to me. Women, I don't love that there's kind of this gap in there, but for the most part, I'd say that both of these histograms look nearly normal. Okay, the fourth condition is that the samples must be independent. So I need to make sure that a person or a participant could not fall into both samples. There's definitely no way that you could be a man and a woman at the same time. So we're going to say that these samples are independent. I'm going to zoom out here a little bit. Okay, my N in phantoms stands for naming the test. Now, when we did this same kind of problem for one sample, we called this a one sample t-test. Now that we have 2 groups, this is called a 2 sample t-test. T in phantoms stands for our test statistic. So this is where we're going to list the averages that actually happened in each sample. I'm going to subtract them just like I did in my hypotheses up here. So I'm going to take my first x and I'm going to subtract the second. Okay, the first x would be for men. So the average GPA for men in our sample was 2.898. and I'm going to subtract the average for women, which was 3.330. Okay, that gave me negative 0.432. Okay, next up in phantoms, we have O, which is the fun part. This is where we are obtaining our p-value. Okay, our goal is to build a model. So again, we need to find a mean and a standard deviation. So I'm going to start off with finding the mean or the average, so what we expected to happen in the samples. So I'm going to write that as the expected value of x bar 1 minus x bar 2. Okay, well, our assumption in the very beginning was that these two groups were the same. We expected men and women to be the same. We expected their difference to be 0, so my expected value should be 0. That should be true for every hypothesis test that we do. Okay, now if you are remembering proportions, the next part that we did for proportions for two groups hypothesis testing was we pooled. When we're dealing with averages, there is no pooling. We do not have to pool for this guy at all, which is nice. Okay, the next thing that I would need to do is find my standard deviation. To find the standard deviation, we're going to use the formula we talked about above. So that was my big square root. I'm going to take the standard deviation for my first group, so men, so 0.583. We're going to square that and divide by the number of men. So that was 13. We're going to add, do the same thing for your second sample. So women had a standard deviation of 0.395. Again, I'm squaring that and then dividing by the number of women, which is 19. Okay, let's go ahead and plug this into our calculator. So we should get a standard deviation of 0.1854. Now that I have a mean and a standard deviation, we can draw a model. So my mean is 0, and my standard deviation is 0.1854. I'm going to drop down my test statistic, which was this value right here, the negative 0.432. So that's negative, so it's going to be to the left of 0. My shading should match my alternative hypothesis, so less than. Okay, from here I need to find a t-score, so I'm going to change this test statistic into a t. So I have negative 0.432 minus 0. I'm dividing by that standard deviation. So we get a t of negative 2.33. Okay, now typically the next thing that we would do in our hypothesis test is use our t-CDF to find this area to our t-score. Okay, now the hard part is we do not have degrees of freedom. Okay, so what's nice is the AP graders are okay if you use your calculator and you just write down the p-value. So we're just going to run this test on our calculator, write down the p-value. They don't need to see that whole t-CDF. So in our calculator, we're going to run this whole hypothesis test. So I'm going to go to Stat, over to Tests, and I'm looking for a 2-sample t-test. That's what we wrote down for naming the test. That's what I'm going to look for on my calculator. 2-sample t-test should be number 4. Now they gave me statistics, they didn't give me the actual data, so I'm going to go ahead and type my statistics in here. So 2.898 with a standard deviation 0.583. There were 13 men. Next one, 3.33, standard deviation of 0.395, 19 in this sample. We were looking for less than, so I'm going to change this to less. Notice it says pooled here. We are never going to pool in stats. In other math classes you might pool, but in AP stats that's beyond our realm. We don't need to do that, so we're just going to keep no for our pooled. We're going to go to calculate. I like to check, make sure your t-score matches. It does, so we're just going to go ahead and put this p-value down, 0.0153. This is your p-value. Okay, in order to get full credit on the AP exam, this is everything that you need to include. You need to have your mean, you need to show where that standard deviation came from, you need to have a picture, and you must include your t-score. If you have all of that included, then you can use your calculator to find that p-value. Okay, the next two pieces of my hypothesis test follow the same as always, so we're going to compare this p-value to 0.05. So since 0.0153 is less than 0.05, we reject H naught. That p-value is small, we reject the null. So making a statement here, if I'm rejecting the null hypothesis, I do not think this null hypothesis is true, which means I do believe that the alternative is true. Okay, so that means that we have evidence that the average GPA for men is less than the average GPA for women. So we have evidence to suggest the average GPA for men is less than the average GPA for women. You may have written this in reverse, so you might have said we have evidence to suggest that the average GPA for women is greater than men. That would have been fine as well. Okay, so hopefully this looks pretty similar. It's nice that we can still use that PHANTOMS acronym. The big difference here is that we need to make sure we're using our calculator to find that p-value.